Hello guys, so in this video we are going to see again another Leetcode problem. Problem number is 236, lowest common ancestor of a binary tree, and the problem is categorized as medium. It's an easy one. Let's see. Given a binary tree, find the lowest common ancestor of the two given nodes in the tree. According to the definition of LC on Wikipedia, the lowest common ancestor is defined between two nodes P and Q as the lowest node in T that has both P and Q and as descendants. Okay, where we allow a node to be a descendant of itself. This is important. Okay, let's see what is LCA first. So LCA means, let's say I have a tree A, which root A has its root, and the tree is defined as D, E, F, N, G. Okay, we need to find the lowest common ancestor of B, C or D, F and F, G, C, A and C, F. If we find this, we will be clear what is lowest common ancestor. So to find it out, first I'll tell you what is it for. We need to find the parent of both the variables that are present, or both the nodes that are present. Okay, here B and C will have a common parent, which is A, correct? So A is the lowest common ancestor of B and C node. Okay, here D and F, it's interesting one, D and F. So for D we'll have a parent as B, and for F we'll have parent of C, but both the B and C will have parent of A. So A is the lowest common ancestor again. These are LCA and nodes P, Q. Okay, mentioned here. And F and G. So here F and G is the child of, or the child of C. So it's the lowest common ancestor. If you notice here, C as well as A, C as well as A, it's A is also A, C are the ancestors, but we will choose C because C is the smallest, that is the lowest common ancestor. Here again C, A, so we need to find C, A. In that case, A doesn't have any further parent node, or even if it has parent node, A will be the lowest common ancestor, because here what we have seen is where we allow a node to be a descendant of itself, so A can be a descendant of itself. Okay, then C, F. So here if C, F again, so C is the lowest common ancestor. So this is clear, right? What is lowest common ancestor now? Let's see a few examples that is given. Okay, so here 5, 1 as P and Q, 5, 1 as P and Q. In that case 5, 1, so its common parent is 3, correct? Okay, and another example where 5, 4, 5 is here, 4 is here. We don't have to bother about 3 because 5 itself has the 5 itself is descendant of it, so 5 is the lowest common ancestor here. And we have 1 and 2. So for this we need to find lowest common ancestor. For 1, 2, it should be 1. The constraints are very important. From these constraints only we are going to frame the solution for this problem. I'll tell you in a moment why. Because the node dot value are unique. Okay, the node dot value are unique. We don't have to bother much about it. All the values in the tree is unique. P not equal to Q, it is an important one. P and Q are not equal. This P and Q will exist here. This is the major thing which is going to reduce the code complexity. P and Q will definitely exist in the tree. So which means if we traverse left subtree and Q or P is not found, then it must be in the right subtree, right? So P, Q not found means we don't have to traverse the right subtree. It must be definitely in the right subtree. You got my point, right? So let's see another example here. Let's say I have A, B, See, this example is how to frame the algorithm to solve this problem. E, F, G. Let's say I have to find C, comma F, lowest common ancestor of C, comma F again. So in this case, I don't have to bother about root dot left, right? First I'll traverse root dot left. First I have to traverse root dot left. The algorithm will go like this. First we'll traverse root, then root of left, then root dot right. Okay, so we already traversed root dot left. In that case, if root dot left does not have C, then root dot right first returns C, right? It returns C first. Then C found first. In that case, we don't bother about F. Don't worry about F, because F is not in left subtree, correct? F is not in left subtree. At the same time, we found C first. In that case, C is the lowest common ancestor. I'll repeat it again. We first traverse root dot left. Inside root dot F, we don't have C or F. We doesn't have neither C nor F. Okay. So say we are going to write subtree and find the C first. In that case, C should be the ancestor, because if F is not present here, then F definitely should be in the tree. Okay, F definitely should be in the tree, but we found C first. That means C is also parent of F. Okay, let's see another example. A, B, C, D, E, F and G. So here let's say we have to find B and G. Okay, we will traverse first root dot left again and root dot right. Okay, if we traverse root dot left first, we will find out B first, then we are returning it. Okay, if we traverse first, we are going to return first element that we find between P and Q, because once we find that element, we don't have to worry about the rest of the tree, because B is retained. Then it will go to root dot right. Okay, in the root dot right, if it finds F, then we will return A. If it does not find F, then we will return B. Okay, why I am telling that is, if F is present in right subtree, then common ancestor will be A. If F not present means it should be B or child of B. Why I am telling that is, we don't have to go further if we find any one of the element in that subtree. If we find any one of the element, then we can return the element. If we find any one and return, traverse other subtree. If we don't find, if we found the another element, return root of the element found already. Okay, these are the base cases that we are going to think about. If you find, if it does not have, then return if the another sub return if. Okay, so what I'm trying to say is, if another subtree does not have second element, return found element itself. Concept is simple. Sorry, in A, B, C and F, A comma B we have to find. In that case, A is found already. A will be first found, right? A will be first found when we traverse the code itself. So A is the common ancestor. Between B and F, B found in the B is in left subtree. If F is found here, return A. Between C and F not in left subtree. In that case, C found first. So return C. Let's see the implementation of the code here. So we have 3 inputs: root, P and Q. Okay, if root equal to null or root equal to P, root equal to Q, return root, because in A, B, C, if we want to find common descent, lowest common ancestor of C comma E, first it will go here. It will check whether A will first go. A equal to null, no. A equal to P, no. First it will check here whether it is null or P or Q, no, neither of it. Then it will go inside tree node of left CA. So lowest common ancestor. So lowest common ancestor of root dot left. Okay, so root dot left first will be traversed. Root dot left will be first traversed, and P comma Q, then root dot right will be traversed, then along with the P comma Q. If left found it first, let's say we have in that A B C example, we have A B and I'll make it clear here. A, B, C. We are going to find D and F. Sorry, C and F. So first it will check B, root dot left will go. So once inside the root dot left, it will check it is equal to P comma Q, which is C comma F. No, it's not true. Then it will go further. The function will calling itself again and again. First it will complete the left subtree. If the element is found, it will be stored in the left LCA. If the element is not found, then it will go to right subtree, and if the element is found here, it should be in the right LCA. If left LCA not equal to null and right LCA not equal to null, return true. This case is for if B, C or the P and Q. If B and C are the P and Q, then A is the common ancestor, least common ancestor. If left CA not equal to null, then return left LCA, which means here let's say we have Y and Z, and we need to find B comma Z. So in that case, we'll first traverse left LCA, we'll find the B will be found, and in the right subtree B won't be found. In that case, right should be null. Okay, So else return write LCA. So let's say we have C comma F here as an example. First C will be found, C found, lifts up tree as null. So we'll return write LCA. So this is the code for the least common ancestor. In case of any queries, please post it. Yeah, thank you.